Hello guys and welcome back. So after this, what we can do now is try to add variations to the planks. Okay, now there are a bunch of variations we can do. One of them is kind of like deleting some of the planks because there are a lot of planks. And another thing we can do is we can cut the planks into smaller planks because this is really long, right? This is like a big long plank, which is impossible. And third thing we could do is varying the length in the middle. Okay, so we still have a lot of things we can do to this. Let's start with cutting. Actually, I wanted to cut more in the middle, so I want to go for each primitive again. Oh, actually not that. I'm gonna do like a for number this time because I don't know how much I'm cutting. This is gonna be something I can define by our interface. Okay, I'm gonna call this guy cutting. And cutting count, and this is cutting end. Okay, we're going to loop several times. Every time when we loop through this, we wanted to actually do something to this. So in this case, what we want to do is every time when we finish that, we feed back the current result. So it's going to feed back the result to the input. The input will fetch the feedback. So that way, we're going to constantly doing something to it, and we got the result, and that result will be the beginning to the next loop, right? So this is going to be keep doing something to this guy. Yeah, that's the logic in here. Okay. Of course, the first loop will still take this input, but after the first one, the second input, the second loop will just use the result of the first loop. Okay, instead of getting this input again. So in this case, I wanted to, for every loop, I wanted to find the longest one and cut it. Okay, so how do we find the longest one? We'll just find the area by doing a measure node to measure the area. Okay, now after measuring the area, you can see on every primitive, we have an area. Okay, and we just get the longest one. So we can do like an attribute promote to promote the area attribute from primitive to detail area attribute. We keep the original one, but we give the new one a maximum value. We get the maximum value for the new one, and the new name will be max area. Okay, so now in the detail, there will be one attribute called max area. It's the maximum value we're getting from all the primitives. And when we know that number, now we can do a blast to basically get a primitive that has the max area. So we can say at area equals to backtit and then detail value of the actually operator input pass. Operator input pass of this node's first input, asking for max area attribute, lowercase m, and we're asking for the first index. This first index is basically saying there could be like a value that is like a vector, and if that's what's happening, then you have to give it an index to get x or y or z of that vector. Okay, right. See, now we're deleting actually not just one, because there could be a bunch of planks that has the same area, which is also the biggest area, right? So that actually has to be further isolated because we wanted to cut one plank every time. So this is going to be the bigger ones for cut. Okay, and then we can Control C, Control V. Oh, this actually delete non-selected. So we got the bigger ones in here. And these ones, the smaller ones, we can say smaller ones keep. So we don't do anything. Eventually we have to merge all those things together after cutting. Okay. So for the bigger ones to cut, then we do like a sort to sort our primitives to random. Okay, a random seed. So that way their numbers are going to be in a random order, right? And we just get, the first one, or get the one that has the 0 primitive number, delete non-selected. Okay. Find one to do cutting. Oh, do cutting. And then this one will be keep. Okay, for the others we just keep them. So that way we have the two small ones we don't want to cut, the ones that wins the lottery and doesn't get cut, and this one is the one that has to be cut. So we cut this one. Okay. So how do we cut this one? Well, we wanted to cut it to be something smaller, like every time we have one line to cut it so that it becomes two pieces. But we don't want it to cut too far away, so it's like cutting here, then that's going to cut a really small plank, which is not ideal, right? So in this case, we wanted to do some calculation to get some cutting information here. Okay, so we can say get cutting information, or calculate maybe. Calculate. Okay, so one thing I wanted to define here, float mean plank length will be equals to a channel called mean plank length. Okay, and we can give it a value like 1, or maybe 1 is too small, or is it? Let's see. So this is this is actually 1, I think 5 maybe. So I want I want everything to be at least 5 unit long, or maybe even a little bit smaller, 4 unit long, right? Anything smaller than 4 will be too small. So we'll make sure that every plank is bigger than that. Okay. Okay. So then what we need to do is we want to cut it, from the center, find a position from the center, but not too far so that that position is within 4 units to the very edge, right? If we can guarantee that, not cutting too far from the center, then we're guaranteeing that both of the planks we cut out will be bigger than 4, or bigger than our plank length. That's the idea here. Okay, so I'm going to say cutting. Oh, create a float number for that. Too much Python recently. Float cutting max distance from center. Well, this is a really long variable name, but this is very explanatory. Like it says exactly what it is, right? The cutting max distance from the center will be the current length. The current length is going to be this get a b box size, and we know that the length is a z, right? So dot z, right? That's going to be the whole length, and then we divide that by 2. That's going to give us the half length, right? And then we minus the mean plank length, so that's going to be the rest of the length will be the freedom that we can cut through, right? So minus the mean plank length. So that's going to give us, a range that's ranging from the center to, to exactly 4 units away from the edge. Okay. All right. So with that being created, then we can just say get a random number out of this, right? So we can say float cut from center will be equals to a random value. Okay, and we can use the current iteration as the driver of the random value, right? So we can say detail attributes of our cut. Let's see, cutting count. Okay, so cutting count. That's basically what that is. So I'll go back here. Say this guy. It's an iteration attribute and 0. Okay, we're gonna random a value like that, and we fit it from 0, 1 to negative and positive of our max cutting from the center. Okay, run it. Okay, got a arrow here. Oh yeah, the detail may return something else, so we kind of have to do this. We cannot encapsulate this thing inside. So we can say, okay, current iter will be equals to this guy, and then we random from current iter. Okay, all right. That way we're getting like a random cutting, a random cut from the center value, and this has to be something carried down to a clip node, so we can make it an attribute. Float at cut from center will be equals to that, and for the primitive, you can see if you go. Oh, we don't do that on the point. We do that on the primitive. Okay, you can see cut from center is that, which is 0, which is kind of not exactly what I want. Okay, let's see. Maybe we got this thing wrong because it was not giving you. Sometimes you have to say operator, and then that. Okay, no. Maybe the size. Oh, you know what? That's actually the size. So 4 is too big. That's why we're getting there over here. 1, 2. Yeah. Okay, that's 2 units away. And let's also create another seed so we can take a look at the random variations. So we can say float seed equals to channel seed. Okay. And we copy that seed here, and we also have that involved. Okay. So that we have another seed, can get out different like random values. Cool. We can hook this seed up later on. Anyway, so this will give us an offset, but there's actually a hidden arrow that could happen here. What if it's too short, so there's no way to cut it? Then your cut value will be something 0, right? Cut value is actually going to be, actually it's going to be negative. It's going to be negative, okay? So I'm going to say if it's negative, then we don't want it to cut, right? Just to be very sophisticated on the logic here, we can say, okay, if we can do that here, if cutting max distance from center is 0 or smaller or equals to 0, that means we do not want to cut, right? We can say I at cut or should cut. This is more like a boolean, but you know, there's no boolean in this language. So yeah, you just have to do this. So if that's smaller than 0, then that's equals to 0, and or otherwise it's going to be equal to 1. So that way we can determine do we want to cut or not. Okay, cool. So you can see this is should cut. Okay, if the mean length is like 5, then it shouldn't cut anymore, right? Because this is too short to cut. Alright, fantastic. So when that is done, then we can go ahead and do our cutting. That's going to be a clip node. Okay. And we're clipping it based on the center of this object. So centroid will be the thing we do, and we're going to ask for the operator input path of our self first input. And we're going to ask for the x dimension for that, and this is going to be y dimension, and this will be the z dimension, right? So we're cutting from that center, and then where's my thing? This is in here. Okay, and we're cutting it. Oh, the direction is x. Okay. And it's not really cutting it properly. Oh, you know what? I think it's cutting that way, which is not cool. Let's keep all primitives. You can see it's cutting this way. So I guess it has to be z instead then. Right, that's z. So now you can see we're cutting it over here. Now we can go here and say seed. Oh, it's not cutting. It's not changing yet because this cutting is always going to be here. Distance is 0. This distance is actually the distance from the center, And that's why we created this attribute called cut from center, right? So all we have to do now is reference that. So we can say it's on the primitive, so primitive attribute of the first input, and then prim number, which is 0, should be fun. You can see the signature here, like surface node, which is, the surface. Oh, actually that should be operator input pass, actually. Sorry about that. Operator input pass of the current node's first input. Okay, and then the number for the primitive number is going to be 0. Attribute name will be cut from center, and then eventually you need to, this has to be quotation mark, and then 0. Okay. Alright, you can see now we're getting a number that's 1.8, which is basically that. And here we can then change the seed. You can see we're cutting it slightly different every time when the seed is different. Okay, and then when that is over, we merge all three back together. Okay, and then connect that result to there. Okay. Alright, now final question is, well, we're cutting all these things, but we're cutting like 10 times for now, so it's 10 times. How many cutting do we really want? Well, that's up to you actually. If you wanted to cut more, you can drag that up more. You can do like 100 and it's gonna try to cut 100 times, right? I think I can lower down the min size so we can, oh, you know what? It needs to cut more to be able to cut these guys. Anyway, yeah. So that's going to be up to the user. So I'm going to go here and create attributes for that. We can go to asset, edit, and our plank generator. We can also just drag this guy over here. Okay, and then we can say cut amount. And it's ranging from 0 to 200, I guess. Accept that. So now it's already connected. Okay, and also we can create parameters to control these, right? So we can go back here and then go to the parameter settings actually. Plank generator actually. This one. I'm gonna drag in two float. One is seed. That's gonna be the seed that could be driving all other seed. Just the seed. And this one is the min plank size length. You want to name your stuff really carefully because it has to make sense. Okay. Alright. I think 3 or 5 maybe is the maximum we can do now. And default value is going to be 1. Okay, accept that. I'll go to parameters. Okay, and copy that parameter and paste it in here. Okay, and copy this parameter and paste it in here. Okay, that way we can use our control panel now to control like cut amount to cut more or less. Right, min plank length can be bigger or smaller. Right, we can then do the seed. Oh, and by the way, we're still cutting really smaller ones because we don't do this. We did do like should cut or not should cut, right? Should not cut this thing. So that's actually when we need to create a switch based on that. Okay, and drag this switch over. So if it's either 0 and 1, so all we have to do is pass this guy in, right? We click on that. So the clipping is the cut one. So when should cut is 0, then we go this. If should cut is 1, then we do this, right? Which is exactly what we want. So all we have to do here is just using that detail attribute. So we can do detail. operator input pass, whichever one, because they are the same in this case. Oh, it's not a detail attribute actually, it's gonna be prim attributes. The first input should be fun, and we can ask for the first primitive attribute is should cut, and ask for the first index. That should work. Actually, it's not working. This is a should cut is actually 1 here. Primitive 0. Let's see. Should cut. Oh, that's not should. That's I'm typing it wrong. Let's change that to should cut. Okay. So should cut in here and should cut in here. Right. Cool. So that's gonna give me should cut values. It's 0. Let's make sure that's the same. Huh, how come it becomes 0? Did I do something? Yeah, this is should cut, which is cool. And it should be, if it's smaller than 0, that's 1, 0, 1. And yeah, that should be correct. But I'm getting a value of 0 here for some reason. So I guess this one should not cut for this particular one, but it should be fun for others. Let's take a look. So if I try to cut a whole lot, if my min is not small enough, then it will not cut, right? Which is good. Okay, cool. Yeah, now we can really control like the unit, the min plex size has to be somewhat bigger than this, otherwise it's not gonna cut. Like you can see this time it's not cutting. It's based on the iteration, right? So yeah, that's why it was having like a different value. Cool. So yeah, that's the logic for the cutting. It actually takes longer than I thought. Something we have to, maybe some more things that I didn't expect to do. Anyway, so all right, so we have the cutting done, which is, we're actually getting pretty cool result now. So I think next step will be adding more variations. Like we can deleting some of the planks, we can add some like tilting to the plank, maybe even make the edge, becomes more like bricked up or rounded, or having like in and out kind of thing. So yeah, let's move on to that in the next video.